These are 4 generations of Tesla Optimus, Tesla's humanoid robots, that could fundamentally transform how we think about labor, manufacturing, and the future of human work. Today, we're diving deep into Elon Musk's latest announcement about the Optimus Gen 4 reveal and the massive production ramp-up of Gen 3 that's happening right now in 2026. What started as a bold promise at Tesla AI Day in August 2021 has evolved into something far more tangible and potentially revolutionary than most people realize. While critics dismissed early prototypes as overhyped demonstrations, Tesla, Inc. has quietly been building the infrastructure for what Musk calls the biggest product ever of any kind, leveraging their Dojo supercomputer's AI training capabilities to power Optimus development. Let's start with what just happened. At the Abundance Summit in March 2026, Musk dropped 2 major bombshells. First, he confirmed that Optimus Gen 3 production will begin this summer, marking Tesla's transition from prototype to actual manufacturing. Second, and perhaps more significantly, he announced that Gen 4 is already in development, with plans to build it at Gigafactory Texas at much higher volumes than the initial 1 million unit Fremont line. To understand the magnitude of what's happening, we need to go back to the beginning. When Musk first unveiled the Tesla Bot concept in 2021, it seemed almost fantastical. 5'8", 125-pound humanoid robot, designed to handle dangerous, repetitive, and boring tasks. The specifications sounded impressive on paper. Carrying capacity of 45 pounds, controlled by the same AI system powering Tesla's self-driving cars, and priced around $30,000. But here's what made Tesla's approach different from every other robotics company. While competitors like Boston Dynamics focused on specialized robots for specific tasks with their Atlas humanoid, Tesla was building a general-purpose humanoid that could theoretically do anything a human could do. More importantly, they were planning to manufacture these robots at automotive scale and automotive prices, competing directly with Chinese manufacturers like Unitree Robotics, whose Unitree G1 humanoid retails for just $16,000. The journey from concept to reality has been anything but smooth. Musk's initial timeline called for production by 2023. That became 2025 with targets of 5,000 to 10,000 units. By early 2025, those numbers were scaled back to just 5,000 robots for internal factory use. Critics like Rodney Brooks called the entire vision pure fantasy thinking. But something changed in the past year. The Optimus program underwent a significant leadership shift when Milan Kovac, who had headed the project since 2022, resigned in June 2025. His replacement? Chuck Elliswamy, the head of Tesla's autopilot teams and a key architect of Tesla's full self-driving technology. The results of that integration became apparent with the Gen 3 reveal in February 2026. When Elon Musk posted "This bot got hands" alongside a new demonstration video, he wasn't just showing off improved dexterity. He was showcasing a fundamental breakthrough in robotic manipulation that represents a quantum leap from previous generations. Let's talk about those hands, because they're arguably the most important component of any humanoid robot. Progression from Gen 2 to Gen 3 tells the story of Tesla Inc.'s engineering evolution. Gen 2 hands had 11 degrees of freedom, impressive for the time. But Gen 3 hands? 22 degrees of freedom with 50 total actuators across both forearms and hands, utilizing advanced tendon-driven hand systems and precise harmonic reducers for each joint. That's a 100% increase in dexterity and a 4.5 times increase in actuator count. What does that mean in practical terms? Gen 2 could handle approximately 500 discrete manipulable tasks. Gen 3 can handle over 3,000. We're talking about the difference between picking up a box and performing delicate assembly work, between moving objects and manipulating them with human-like precision using planetary roller screw actuators that provide unprecedented force control. Hands alone represent a manufacturing challenge that most people don't appreciate. Current estimates put the cost of each Gen 3 hand assembly between $30,000 and $80,000. That's unofficial, but it gives you a sense of the complexity involved. Tesla is essentially building precision surgical instruments at scale, then integrating them into a walking, thinking robot that needs to operate reliably in factory environments. This brings us to the production timeline that's unfolding right now. Summer 2026 marks the beginning of Gen 3 production, but Tesla isn't starting from scratch. They've been preparing for this moment by repurposing existing manufacturing infrastructure in ways that would make traditional automakers nervous. Remember the Tesla Model S and Tesla Model X? Musk announced in early 2026 that Tesla is ending production of both vehicles to free up factory floor space at Tesla Fremont factory. This isn't just about making room. It's about converting automotive production lines into humanoid robot manufacturing facilities. The expertise Tesla gained from scaling electric vehicle production is now being applied to scaling robot production. The numbers are staggering when you consider the implications. Tesla is targeting a 1 million unit annual production capacity at Fremont, with plans to reach that volume by the end of 2026. But that's just the beginning. The new Optimus facility at Gigafactory, Texas, which broke ground in late 2025, is designed for even higher volumes. Musk's ultimate goal? 10 million units per year. To put that in perspective, the entire global automotive industry produces roughly 80 million vehicles annually. Tesla, Inc. is planning to manufacture robots at roughly 1/8 the scale of the entire global car industry. If they succeed, Tesla Optimus could become the most manufactured product in human history. The financial projections are equally mind-bending. Elon Musk predicts that Optimus robots could generate over $10 trillion in revenue long-term, potentially becoming the most valuable part of Tesla's business. To support this vision, Tesla announced $20 billion in capital expenditure for 2026, more than doubling their previous investment levels. But let's be realistic about the challenges. Tesla has a history of ambitious timelines that don't always materialize on schedule. The company never came close to producing thousands of Optimus robots in 2025 despite repeated promises. Even now, on Tesla's Q4 2025 earnings call, Musk acknowledged that current Optimus units are primarily for learning, not productive tasks. This honesty about current limitations actually strengthens the case for what's coming next. Tesla is being transparent about the fact that they're still in the research and development phase, even as they prepare for mass production. The small fleet of Optimus robots currently operating at Gigafactory, Texas, dozens of units performing battery cell sorting, component kitting, and inventory management represents real-world testing that's informing the Gen 3 design. The competitive landscape makes Tesla's timeline even more critical. Figure AI is already deploying humanoid robots in car factories. Agility Robotics operates a bipedal robot production line called RoboFab in Oregon for logistics purposes. Texas-based Apptronik is testing its Apollo model. In China, competitors are moving fast. Jack Ma's Ant Group unveiled R1, a robot that cooks and serves food, while UB Tech Robotics' Walker S1 humanoid is already deployed in BYD company auto factories, and 1X Technologies' NEO humanoid is shipping to consumers at $20,000. Silicon Valley unicorns like Figure AI and 1X Technologies have raised significant funding and are racing toward commercial deployment. The window for Tesla to establish dominance in humanoid robotics isn't infinite, and the company knows it. This competitive pressure explains why Tesla is already talking about Gen 4, while Gen 3 hasn't even begun production. At the Abundance Summit, Musk provided no specifications, timeline, or pricing for Gen 4, but his brief mention signals Tesla's commitment to staying ahead of the development curve. Based on Tesla's historical pace, 14 months from Gen 1 to Gen 2, 24 months from Gen 2 to Gen 3, a Gen 4 reveal in late 2027 or 2028 seems likely. The technical specifications we do know about Gen 3 reveal the sophistication of Tesla Inc.'s current engineering. The robot stands 5 feet 11 inches tall and weighs 160 pounds with over 40 degrees of freedom throughout its body. It runs on a 2.3 kilowatt-hour battery, enabling nearly all-day operation, with exceptional energy efficiency ranging from just 100 watts at rest to 500 watts while walking. The AI chip powering Gen 3 is Tesla's AI5, providing approximately 5 times the memory bandwidth of Gen 2. More intriguingly, Gen 3 integrates with xAI's Grok large language model for natural language task instructions. This means you could potentially tell an Tesla Optimus robot what to do in plain English, rather than programming specific movements. This integration raises fascinating questions about the relationship between Tesla and xAI, Elon Musk's artificial intelligence company. The Digital Optimus project, also called MacroHard, represents a joint venture that will use Grok to power computer-controlling AI agents. It's part of Tesla's $2 billion investment agreement with xAI, but it's also attracted shareholder lawsuits alleging that Musk is diverting Tesla resources for personal benefit. These legal challenges highlight one of the most controversial aspects of Tesla's robotics program: the concentration of decision-making power in Elon Musk personally. When he posts "This bot got hands" on social media, he's not just sharing a product update. He's making strategic announcements that move markets and shape investor expectations. The reliability concerns are real and documented. At a Tesla event in Miami, one Optimus robot fell backward after making upward motions, highlighting balance and reliability challenges outside controlled environments. Bloomberg and other outlets reported that robots at the We Robot event in October 2024 were being remotely operated by humans, with at least one video showing an Optimus bartender acknowledging human assistance. These incidents underscore the gap between demonstration and deployment. Building robots that can perform reliably in real-world environments, day after day, without constant human oversight, remains an enormous engineering challenge. Tesla's transparency about these limitations, while potentially damaging to hype, actually builds credibility for their long-term approach. The supply chain challenges alone are staggering. As Musk noted, the manufacturing challenge is immense, considering that the supply chain doesn't exist. With cars, you've got an existing supply chain. With a humanoid robot, there is no supply chain. Tesla is essentially building an entire industry from scratch, from specialized actuators to AI chips to battery systems optimized for robotic applications. China's 2025 export restrictions on rare earth magnets used in Optimus actuators illustrate the geopolitical dimensions of robotic manufacturing. Tesla had to seek export licenses to continue importing components, highlighting the strategic importance of humanoid robotics in international competition. The hiring surge tells its own story about Tesla Inc.'s seriousness. The company has posted over 100 job openings across U.S. facilities, from AI engineers to manufacturing specialists, signaling a pivot from prototypes to production lines. This isn't the hiring pattern of a company engaged in speculative research. It's the pattern of a company preparing for mass manufacturing. Consumer availability remains the ultimate test. Elon Musk's current target is end of 2027 for consumer sales, with an estimated retail price around $30,000. Tesla's goal is to reach a production cost of $20,000 per unit, though current estimates suggest unit costs between $50,000 and $100,000. The path from current costs to target pricing depends entirely on achieving massive scale. This is Tesla's core competency. They've done it with electric vehicles, with batteries, with solar panels. The question isn't whether Tesla can scale manufacturing, but whether they can do it fast enough to maintain their technological lead. Looking ahead to Gen 4, the possibilities become even more intriguing. If Gen 3 represents Tesla's transition to mass production, Gen 4 could represent their transition to mass adoption. Higher volumes at Gigafactory Texas suggest not just incremental improvements, but potentially fundamental advances in capability, cost, and reliability. The implications extend far beyond Tesla's business model. We're witnessing the potential birth of an entirely new category of consumer product: personal humanoid robots that could transform how we work, live, and interact with technology. Whether that future arrives in 2027 or takes another decade, Tesla's current trajectory suggests we're closer to that reality than most people imagine. As we watch Gen 3 production ramp up this summer and await details about Gen 4, we're not just observing product development. We're witnessing the early stages of what could become the most significant technological transformation since the personal computer. The question isn't whether humanoid robots will become commonplace, but who will build them, how quickly they'll improve, and what that means for the future of human work itself.